Good morning, everyone. Today we are covering an important topic. The name of the topic is chemical reactions and equations. It is one of the most important topics of class 10 CBSE board examinations or science textbook, and it is the first chapter. So, in this chapter, we'll try to go in depth and try to understand what are the chemical reactions, how to write the equations, and what are the different types of chemical reactions that are present in the nature. This video will be divided into two parts. So this is the part 1. Upon completion of part 1, part 2 will also be uploaded. Let's start the chapter chemical reactions and equations. Now we start with the introduction, and first of all we try to understand what exactly is a chemical reaction. Chemical reaction is a process in which one or more reactants are converted to one or more products. So it's a very straightforward definition. Chemical reaction is a process in which one or more reactants are converted to one or more products. So during a chemical reaction, some chemical change occurs. The substances that undergo chemical change are called reactants, and the new substances formed are called the products. See, there is a sample reaction giving in the introduction part. These are the reactants. CH4 is the methane gas. Whenever it reacts with oxygen, it forms carbon dioxide and water. So in this reaction, methane and oxygen are the reactants. Upon reacting, they are giving us carbon dioxide and water, which are the products respectively. So hope this topic is clear, the definition part and the example of reactants and products. Now let us move forward and understand different chemical reactions and just try to understand that how do we know that a chemical reaction has taken place? What are the physical symptoms? So first of all, we try to understand the reaction of a magnesium ribbon. There is a white magnesium ribbon which has been taken up and it has been held by tongue, something called as tongue. And we use a burner to burn the magnesium ribbon. Upon burning, this is what happens. The magnesium ribbon burns with a white flame, dazzling white flame, and it forms a white powder called magnesium oxide. This is the magnesium oxide white powder, which we collect in the watch glass or the china dish. This reaction is due to the reaction of magnesium with oxygen in air. So it can be written as Mg plus O2 is equal to 2MgO. Okay, so magnesium oxide has been formed in this reaction because a burning of clean magnesium ribbon had taken place. This is the second reaction. In this reaction, we have taken a lead nitrate solution in a test tube. We have added potassium iodide solution into it. This is lead nitrate, potassium iodide solution has been added over it. And we get to see two different things, that a yellow precipitate of lead iodide appears at the bottom. This is something called as the precipitate, a residue that remains into the base of the solution. A yellow precipitate of lead iodide appears at the very much bottom. Okay, so what is the reaction? Lead nitrate solution in a test tube, we added potassium iodide, we get a yellow precipitate of lead iodide and it appears at the bottom. This is the reaction. So what changes did we see? There is a change in the color. There is a precipitate formation in this. Okay. Third reaction we see is the reaction between zinc and sulfuric acid. Sulfuric acid is a strong acid. Zinc is a metal. We get the formation of zinc sulfate and hydrogen gas is evolved. So we take few zinc granules in a conical flask or test tube. We add HCl or H2SO4. Bubbles are observed around zinc granules due to release of hydrogen and conical flask becomes hot. So we see two things. There is an evolution of hydrogen gas in this reaction and the conical flask has become hot. So two things that we observe is evolution of gas and the temperature has risen and the flask has become hot. Okay, so the following observations help to determine whether a chemical reaction has taken place. So how do I know a chemical reaction has taken place? What are the four physical things that happen? So first thing is change in state. We will see some change in state. We will see some change in color, like in the second reaction. We will see an evolution of gas, like the hydrogen gas was evolved in the third reaction. we will see a change in temperature. Because the beaker became hot, we can say that a change in temperature has happened. Heat has been evolved. So such reactions are called exothermic reactions. The reactions wherein heat is released or the beaker becomes hot is called a exothermic reaction. Heat giving reactions or heat evolving reactions. Okay, clear? Let's go ahead. Now we try to understand what is a chemical equation. So description of a chemical reaction can be written in a shorter form. Simplest way is the word equation. Like we write magnesium plus oxygen in word form is magnesium oxide. These are the reactants, these are the products. Reactants are written on the left hand side. As you can see, magnesium and oxygen are reactants. They are written on the left hand side. Magnesium oxide is a product, so it is written on the right hand side. And there is a plus sign between the reactants, as we can see here. Products are written on the right hand side, RHS, with a positive between them. The arrowhead points towards the product and shows the direction of the reaction. Okay, so this is the chemical reaction. This is how we write it in words. Okay. Now we go ahead how to write a chemical equation. Chemical equations can be simplified by using chemical formulae. A chemical equation represents a chemical reaction, like we write Mg plus O2 is MgO. If the number of atoms of each element is not same on left hand side and right hand side, equation is unbalanced. It is called skeletal chemical equation. Skeletal chemical equation is the equation in the rawest form, unbalanced. If same, it is balanced. So we see that magnesium has, see, this is not balanced. Magnesium has one, magnesium has one. Magnesium balanced. Oxygen has two atoms, but here oxygen does not have two. So what do? We add a 2 in front of MgO. 2 MgO. So now oxygen are balanced, but magnesium becomes 2. We need magnesium 2, so we add a 2 here as well. Same thing has happened. 2 Mg plus O2 is 2 MgO. So this is a balanced chemical equation. 2 atoms of Mg, 2 atoms of Mg, both on LHS and RHS. Oxygen has 2 atoms, and here oxygen also has 2 atoms. So this is an example of a balanced chemical equation. Next we go and understand that why is it important to balance a chemical equation. This question is asked in the board exams. Why should we balance a chemical equation? Why is it necessary? Why is it important to balance a chemical equation? So the answer to this question is the law of conservation of mass. There is a law, that is the law of conservation of mass. The law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Total mass of the elements present in products is equal to total mass of the elements in the reactants. So that is why in order to fulfill this law of conservation of mass, balancing is carried out, and balancing is important. Number of atoms of each element remains the same before and after a chemical reaction. So skeletal chemical equation must be balanced. Word equation of chemical reaction is zinc plus sulfuric acid is zinc sulfate plus hydrogen. It is represented as Zn plus H2SO4, ZnSO4 plus H2. So this is a balanced equation. Zinc is 1, 1. So you can make a table, number of atoms in reactant LHS, number of atoms in product RHS, and by doing so you can determine if all the elements are balanced. So zinc has one atom, balanced. Hydrogen has two, hydrogen has two, balanced. S has one, balanced. Oxygen has four, oxygen has four. So this is a balanced chemical equation. Okay, so I encourage the students to make a table and write down the atoms for each element and then determine if the equation is balanced or not. If it is unbalanced, they need to add the number of atoms in front of the different elements accordingly to boil in order to balance the chemical equation. Let us see ahead, and this time we are taking an example. These are the steps of balancing a chemical equation. See, balancing a chemical equation using least whole number coefficient. So we have a reaction Fe is iron plus H2O, Fe3O4 plus H2. First thing I notice is I make a table. I make boxes around each formula, and I just make a box and I make a big table wherein I list all the elements. I write down all the atoms in the reactant and all the atoms in the product side in order to determine what is balanced and what needs to be balanced. First is iron. Iron has one atom in the reactant side. Iron has three atoms in the product side. So what I can do in order to balance iron is I can add a 3 in front of Fe in the reactant side. If I do this, Fe gets balanced. For hydrogen, I don't need to do anything. It is balanced on both the ends. For oxygen, I have 1 in the LHS, and oxygen, I have 4 in the product. What I can do, I can add a 4 in front of H2O. The oxygen atoms get balanced. Now then what happens, the issue is that hydrogen also becomes 8. 4 twos are 8 hydrogen. So I need to add a 4 here as well. The answer is 3Fe plus 4H2O is Fe3O4 plus 4H2. That is the chemical balanced equation. And I hope my explanation has been understood properly. So as you can see, the same thing will be explained by these decks. Partly balanced, they will take each element and balance, and this will be the final answer as I had explained. Now if we see here 3Fe, Fe is 3 here, 4 into 2 means 8 hydrogen, 4 into 2 8 hydrogen here, 4O means 4 oxygen. So this is a completely balanced reaction. This is how you balance a chemical equation. So I hope by following this method and by following this example, the students have understood how to balance a chemical equation. So this is a very good example to make students understand the balancing of chemical equations. Now let us move ahead and see, the same thing has been explained. In the end, what people do is, or it is a good practice to write down the physical states, like iron is a solid, so he has written solid. H2O in the form of, if you write water as gas, it means it's a steam. If it's a liquid, we'll put L, but if you have given it as gas, if you have written it as gas, it's a steam. Fe3O4 again a solid, and 4H2 is a gas. So I hope till here everything is clear to us. So let us move ahead. Now we get one more chemical equation and sometimes reaction conditions. Now this is another important concept we need to understand. Sometimes there will be reactions with some certain conditions, like the temperature will be mentioned, the pressure will be mentioned, the catalyst will be mentioned. Now what is a catalyst? Catalyst is a chemical that is used in order to make the reaction take place faster. It is used to assist the chemical reaction. In order to make the reaction take place faster, a catalyst is used. Are indicated above or below the arrow in the question. So CO, carbon monoxide plus 2 hydrogen, 340 atmosphere is the pressure, CH3OH is the compound form, 6O2 plus 12H2O. See, this is the second reaction. This reaction is very important. We have 6 atoms of carbon dioxide in aqueous form plus 12H2O water. We have sunlight is a catalyst. Chlorophyll is present in the green pigment of leaves. This reaction is the reaction called as photosynthesis. I encourage students to memorize this reaction, the reaction photosynthesis, because photosynthesis is something that you will study in life processes, that how plants will make their own food. They do it by using photosynthesis. So we want students, or we encourage students to memorize this entire formula. 6CO2 carbon dioxide plus 12H2O water in the presence of sunlight in the green pigment of the leaves called chlorophyll. These are both catalysts. Glucose is formed. Glucose is the food. C6H12O6. 6 should be in the smaller, like how C6 and H12 is there. Plus 6O2 oxygen plus 6H2O. So this reaction is a photosynthesis reaction. And see, this is the perfect way to write a chemical equation. You mention their physical state, you make sure they are balanced, both LHS and RHS. You have to mention the catalyst, the sunlight and the chlorophyll. So I hope the part 1 of this chapter is pretty much clear, wherein we have understood the definition of a chemical reaction, the reactant, the products. We have seen what are the 4 to 5 different ways to ascertain that a chemical reaction has taken place. We have learned how to balance a chemical equation, how to write a chemical equation, how to make a chemical equation more informative by including different temperature, pressure, catalysts, etc. So this is what we will cover till part 1, and we will be back with the part 2, wherein we will discuss different type of chemical reactions like combination reaction, displacement reaction, double displacement reaction, decomposition reaction, oxidation, reduction, redox reactions, corrosion and rancidity. So we keep this first part video till here. I hope the students enjoyed the video. We will be back soon with the part 2 for this chapter. Thanks a lot.